Okay, so for the graphs of the cosecant, secant, tangent, and cotangent, we need to follow this. The function cosecant and secant have period of 2 pi. So given that cosecant is x plus cosecant x plus 2 pi is the same as cosecant x, and then secant x plus 2 pi is the same as secant x. In addition, for the tangent and the cotangent, its period is pi. Okay, so as you can see here, for the sine, cosine, and its reciprocal, the cosecant and secant, its period for its parent function is 2 pi. But for the tangent and cotangent, that is only pi. Okay, so given that we have here tangent x plus pi, that is tangent x. And then cotangent x plus pi is cotangent x. Okay, so let's proceed first with the graph of the cosecant and the secant function. Okay, so first off with the graph of cosecant, so again, we're going to use the concept of its reciprocal, the sine function. So given that we have y is equal to cosecant x, that is the same as y is equal to 1 over sine x. Wherein, we will limit that the value of sine x should not be equal to 0. Okay, so that will be undefined, of course, if we were going to have the value in our denominator as 0. So if we're going to recall the graph of the sine, we have this. And then for us to identify the cosecant graph, all we need to do is to reciprocal all its values. Okay, so if we're going to reciprocal that, here's what will happen. Okay, that 0 will be undefined, and then 1 is still 1. 0 again is undefined, and negative 1 will still be negative 1. And then 0 again is undefined. So if the x is equal to 1 for the sine, it is the same for the cosecant. If it is equal to negative 1, it's the same for the cosecant also. However, when it comes to its x-intercept, or if y is equal to sine x, the y is equal to cosecant x is undefined. Okay, since it's undefined, it will become a vertical asymptote in our graph. Okay, so when sine x is close to 0, the value of cosecant x will have a big magnitude with the same sign as the sine x. So as you can see here, all those undefined values here will become our vertical asymptote. So that 0 is asymptote, that pi, and then that's the 2 pi is also is our asymptote here. So as you can see here, we have the sine y is equal to sine x as our graph. And then for us to graph the cosecant, all we need to do is to, again, reflect it. Okay, so what will happen to this? So the graph will become like this. Okay, the graph will become like this. Okay, so as you can see here, it will approach only to its vertical asymptote. Okay, but it will not touch it. Okay, same with this. It will only approach the vertical asymptote, but it will not touch it. Okay? Now, how about for the secant? So obviously, when it comes to the secant, its reciprocal is cosine. So again, we're going to use the concept of the cosine function. So again, we're going to limit that cosine should not be equal to 0 because it will become undefined. So again, the graph of the cosine here is this one. So all we need to do is to reciprocal its values. So here's what will happen. So 1 is still 1. But 0 again will become undefined. Negative 1 still negative 1. 0 again is undefined. And 1 is still 1. So as you can see, those undefined here will become the vertical asymptotes of the graph. Okay, so here's the graph of the cosine x. And then let's just put the asymptotes here. In pi over 2, x is equal to pi over 2, and x is equal to 3 pi over 2. Then again, just reciprocal the value. As you can see, we're just going to reflect its graph. And remember again, it will just approach its vertical asymptote, but it will never touch. So as you can see, we have here this one, and then this one. Okay, that is the graph for the cosecant and secant function. So let's identify its properties. So as you can see here, its domain and its range. The domain is all real numbers, but the sign x should not be equal to 0. Or simply, in general, x is an element of all real numbers, such that x is not equal to k pi, where k is an element of all real numbers. Okay, so as you can see here, the pi, the 2 pi, negative 2 pi are all the asymptotes for this function, for the cosecant function. And then for the range, as you can see, we have here from negative infinity, so it starts from the bottom until negative 1, inclusive. And then there's a discontinuous part here. Then let's have the union, 1 to positive infinity, 1 to and upwards. Okay, so the range is from negative infinity, comma negative 1 inclusive, union 1 inclusive, comma positive infinity. And then for the domain of the secant function, so obviously the cosine x should not be equal to 0. So it's x is an element of all real numbers, but such that cosine x should not be equal to 0. Or simply as x should not be equal to k pi over 2, where k is an odd integer. So as you can see here, we have pi over 2, 3 pi over 2, pi over 2 as our asymptotes. And then for the range, same with the nature of the cosecant, we have negative infinity, comma negative 1, inclusive, union 1, comma positive infinity. Let's have another example for the cosecant and secant. Okay, so as you can see here, as you notice, the amplitude is, there's no amplitude here. Okay, there's no amplitude here because based on its definition, it identifies the height of the function. But in this case, it extends both from negative infinity and to positive infinity. So therefore, our amplitude here is none. Okay, and our period still is 2 pi, since it's just the reciprocal of the sine and the cosine function. So again, an appropriate interval on which the graph one complete period is from 0 to 2 pi over b. So same formula for the period. So given that we have 3 secant x over 2, the period here is 2 pi over 1/2, which is equal to 4 pi. Okay, so as you can see here, our b here is 1/2. Okay, so again, we don't have an amplitude here, so we're not going to identify it because it's nothing. And for us to identify the points that we're going to use, again, we're going to use the interval 0 to 4 pi. And then if we're going to divide it again into 4 equal parts, it will be 0 pi, 2 pi, 3 pi, 4 pi. So those are the points we're going to use. So again, substitute it to our formula, to our function 3 secant x over 2. So if we're going to substitute that 0, the result of that is 3. And then for the pi, the result of that is undefined. So again, in your calculator, again, use the reciprocal. Okay, just use the reciprocal. So you can use the cosine function and then reciprocal it. Okay, then for 2 pi, that is negative 3. And then for 3 pi, that is undefined. And then for the 4 pi, that is 3. Then let's graph it. So remember, its nature, the graph of our secant function here. Okay, so as you can see, pi and 3 pi will become our asymptotes here. And then we have here 0, 3, so it will approach like this. And then 2 pi, negative 3 will have this. And then for 4 pi comma 3 will have this. Okay, let's just extend it to pi pi so you can see the whole graph. Okay, for until the 5 pi. Okay, so as you can see here, again, it only approached the asymptotes, the vertical asymptotes. Another example. Y is equal to 1/2 cosecant 2x plus pi over 2. So as you can see here, aside from its, we're going to identify its period, we also need to use the phase shift. Okay, we have here a phase shift. But for us to have that, let's express it wherein we have here just x in our angle here. So it will become 1/2 cosecant 2 times the quantity of x plus pi over 4. So all you need to do is to factor out 2 and then you'll obtain this. Okay? Then after that, we're going to identify the period and the phase shift. So in this case, our period here is 2 pi over b, which is 2, that is pi. And then for the phase shift, that is x plus pi over 4. Then all you need to do is to equate it to 0. You'll obtain negative pi over 4. So again, since we have here a phase shift, a horizontal shift, we're going to start at negative pi over 4. Okay, then add again the period, which is pi. So negative pi over 4 plus pi, that is 3 pi over 4. Okay, then we'll have that interval from negative pi over 4, comma 3 pi over 4. Okay, and we'll obtain that 4 parts, negative pi over 4, 0, pi over 4, pi over 2, 3 pi over 4. And then again, we're just going to substitute it in our function. Then we'll obtain undefined, 1/2, undefined, negative 1/2, and then undefined. Then again, we'll have the vertical asymptote for negative pi over 4, pi over 4, and 3 pi over 4. Then again, plot it. So 0, 1/2 here is this one. And then we have, all we need to do is to just extend it. Approach both the asymptotes in the left and the right. The vertical and asymptotes here. And then for pi over 2, comma negative 1/2, we'll have this. And then if we're just going to extend it, okay, this graph is enough for the period. Okay, but if we're just going to extend this, we will have this one. Okay, pi, comma 1/2 here. And then another one will have the pi over 4 as another vertical asymptote. Okay, so if we're going to extend, you'll have this graph. Now, what about the graphs of the tangent and cotangent? So for the graphs of the tangent, so again, we're just going to use its the nature of the sine and the cosine. Okay, we're just going to use the setup for the sine and the cosine. So tangent x can be expressed as sine x over cosine x. So wherein, again, we will limit that cosine x should not be equal to 0. So if we're going to, again, use the values, 0, pi over 2 pi, 3 pi over 2, and 2 pi. So if we're going to substitute that to tangent x, that is 0, undefined, 0, undefined, and 0. So obviously, again, we have here, again, undefined values, which will become our vertical asymptotes. And then if you want to extend it to identify more values, you can identify its average, again, of the two values here. Let's say 0 and pi over 2. Divided by 2, that's pi over 4. Pi over 2 and pi, that is 3 pi over 4, and so on. For you to identify the different values. Okay, for you to be precise in graphing the tangent function. So if you're going to substitute pi over 4, that's 1. 3 pi over 4, that's negative 1. 5 pi over 4, that is 1. So as you can see here, this will be the graph of the tangent function. Okay, this will be the graph of the tangent function. So as you can see here, 0, 0, we have this. The pi over 2 is an vertical asymptote. And then 2 pi, that is pi, that is 0, this one. Same as with 2 pi if you're going to extend this. Okay, so as you can see, we have pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2 as our vertical asymptotes. And then for you to identify its nature, so as you can see here, pi over 4 comma 1. So we have this one, pi over 4 comma 1. Then extend it, approach it to the vertical asymptote. Okay, so then for 3 pi over 4, that is negative 1. So this one is here. Just extend it and then approach the vertical asymptote. And then for the pi over 4 comma 1, so we have here, then extend it, just approach the vertical asymptote. So the nature of the graph of the tangent function is this one. Okay, this is the nature of the tangent function. Okay, so for the domain, it's an element of all real numbers, but the cosine should not be equal to 0. Okay, same with the nature of the secant, if you will recall. Okay, so x is an element of all real numbers such that x should not be equal to k pi over 2, where k is an odd integer. And then for the range, so as you can see, it approach both the negative infinity and positive infinity, so therefore the range here is all real numbers. Okay, for the period, remember again, that is pi. Okay, the period here is pi. It's not b, correction. It should not be b equals to. Okay, the period is equal to. Okay, so correction eh. Okay, kasi part of b is only in the general form, not its the whole period. Okay, so correction with this in our previous slides also. Okay, so our period here is pi, again, correction, and our amplitude is none. Okay, we don't have an amplitude for tangent and cotangent. And the graph completes a period from negative pi over 2 to pi over 2. So from this, negative pi over 2 until pi over 2. It completes one period. For cotangent, again, we're going to express it in terms of sine and cosine. So we'll have cosine x over sine x. And then we'll limit it again, the x should not be equal to 0. So same procedure, just use the 0, pi over 2 pi, 3 pi over 2, 2 pi, and its values between for you to identify its points to use to plot the cotangent function. Okay, so as you can see here, you have undefined values again, so therefore you'll have vertical asymptotes here. So in this case, our vertical asymptotes are 0, pi, we have 2 pi as our vertical asymptotes. Okay, that is negative pi, negative 2 pi, and so on. So as you can see here, again, that pi over 2 and 3 pi over 2 is 0. So this one and this one. And then we have pi over 4, again, this one here is just 1. So extend it, connect it, and then approach the vertical asymptotes. And then for 3 pi over 4 here, we'll have negative 1. So this one. So again, just connect it and approach it, the vertical asymptotes. The vertical asymptote. And then for pi over 4, that's 1. So again, approach it. Okay, approach the vertical asymptote here. Okay, so the nature of the graph of the cotangent x is this one. In addition, for the domain, same with the cosecant. So as you can see here, we limit that sine x should not be equal to 0, which is x is an element of all real numbers such that x should not be equal to k pi, where k is an element of all real numbers. And then for the range, obviously, as you can see, it approached both the negative infinity and the positive infinity here. Okay, and then for the period, again, correction, it should not b equals to just pi. Okay, the period is pi here, and the amplitude here is none. And then for one period, it completes from 0 to pi. Okay, so from 0 to pi. So for graphs of tangent and cotangent, remember again, an appropriate interval on which the graph 1 complete period of tangent function here is negative pi over 2b, comma pi over 2b, and the cotangent function is 0, comma pi over b. Okay, remember, the period for the tangent and cotangent should be pi over b. Okay, so for sine, cosine, secant, cosecant, that is 2 pi over b. For the tangent, it's just pi over b. Remember that. Okay? So we have your y is equal to 2 cotangent x over 3. So for the period, again, pi over b. Wherein our b here is 1/3. So pi over 1/3 is 3 pi. In addition, we're going to identify the interval from 0, 3 pi, and we divide it to 4 equal parts. And those 4 equal parts are 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, then 3 pi. Then again, just substitute it in our function, and we'll obtain undefined 2, 0, negative 2, and then undefined. So let's just graph it. So again, undefined in 0 and 3 pi. So that will be our vertical asymptotes. So 3 pi over 4, comma 2, and then 3 pi over 2, comma 0, and then 9 pi over 4, comma negative 2. So as you can see here, 3 pi over 4, comma 2, 3 pi over 2, comma 0, and then 9 pi over 4, comma 2. Negative 2 rather. So just approach both the asymptotes, x equals 0 and then x equals 3 pi. Okay, so as you can see here, just approach it, and also here, just approach it. Okay, this will be the graph of the function y is equal to 2 cotangent x over 3. Okay, so for the last example here, we have y is equal to tangent 2 quantity x minus pi over 4. Okay, so in this case, we have the b as 2. So if we're going to substitute in our formula in the period for the tangent, that is pi over 2. And then for the phase shift, we just need to equate it to 0. So c is equal to positive pi over 4. Okay, it should be pi over 4. Okay, then this one, we need to equate it in the period of the tangent function, parent function, from negative pi over 2 to pi over 2. So in this case, we'll have this. 2 times the quantity of x minus pi over 4 is equal to negative pi over 2. So again, remember the period that completes one period or one cycle in tangent is from negative pi over 2 to pi over 2. So all we need to do is to equate this to this root. Okay, so 2 times the quantity of x minus pi over 4 is equal to negative pi over 2. Then if we're going to evaluate that, we'll obtain x is equal to 0. And then here, it ends at 2 quantity x minus pi over 4 is equal to pi over 2. So if we're going to evaluate this, we're going to obtain x is equal to pi over 2. Okay, so we'll start from 0 to pi over 2 for our interval. So if we're going to divide it into 4 equal parts, that will be 0, pi over 8, pi over 4, 3 pi over 8, and then pi over 2. Okay, so let's substitute it in our function. Then we'll obtain undefined, negative 1, 0, 1, and then undefined again. So here, x is equal to 0 and x is equal to pi over 2 will be our vertical asymptotes. Okay, it will become our vertical asymptotes here. Then we're going to plot this. Pi over 8, comma negative 1, and then pi over 4, comma 0, and then 3 pi over 8 comma 1. So as you can see here, we have this one, and this one. Then extend it both sides, just approach it both on the asymptote. So as you can see here, it's trend going downwards, approaching the vertical asymptote x is equal to 0. And then this one, approaching it, the vertical asymptote x is equal to pi over 2. So here's the graph of the function. Y is equal to tangent 2 times the quantity x minus pi over 4.